A nurse started the order at 17:30 hours. Okay. And it was Dextro 5 water, 1 liter IV infusion with a flow rate of 125 milliliters per hour with a drop factor of 15 drops per milliliter. So I just want to do a little light talk about the drop factor. The drop factor is the actual needle that's in the tube that's connected to the patient's hand, wrist, arm, and then the tube goes up to the IV bag. So the tube and the needle that's connected to the patient doesn't change. So that's called the drop factor. It does not change. Now we can change out the IV bag during the process, but you're not going to change out the actual drop factor. There is a 60 drops per milliliters, a 20 drops per milliliters, a 10 drops per milliliters, and this 15 drops per milliliter. And as the drops per milliliter gets as a bigger number, the drops become smaller. Infusions, anytime you're talking about infusions, you will not take a partial drop. So you cannot say point something drops per minute or per hour or however it's calculated. You cannot say that. So we always round to the nearest whole number. So those are two things that I wanted to let you know right at the start. So let's solve for this. One, I noticed I wasn't given the infusion time. I was told the volume that's to be infused, which is 1 liter. And 1 liter we know is 1,000 milliliters. And we were told they were going to do an infusion flow rate of 125 milliliters per hour. So I can solve for the time based upon that information given me. So we'll take that 1,000 milliliters and divide that by 125, and that tells me they're going to infuse for 8 hours. So we're going to put that here. If this nurse starts it at 17:30, we want to know what time the completion time will be. We're going to add that on to the 17 because the first 2 digits in the 24-hour clock time is the hours, the last 2 is the minutes. So now I got 8 plus 7, which is 15, carry the 1. Now I got 25:30. However, there's only 24 hours in a day, so we're going to subtract the 24 from the 25. And now we have a completion time of 01:30, which is 1:30 a.m. Okay. Now let's move to the next part. The next part says, let's solve for the flow rate in drops per minute. So this is the original flow rate. They have already calculated the original flow rate, milliliters per hour. Let's figure out how many drops per minute. So we're talking about a gravity drop. We're not talking about a pump. We're talking about the actual IV bag that's connected to this gravity drop. Okay, or this drop factor. So I'm going to take that 125 milliliters per hour, and we're going to multiply it by the drop factor. And since we want it per minute, I know that I can put in the place of that hour 60 minutes because we know there's 60 minutes in an hour. The milliliters reduce. You can reduce this 15 and 16 or 15 and 60 if you would like, or you can multiply straight across and divide. It's up to you. However, I'm going to go ahead and I'm going to reduce. I know 15 goes into itself once and it goes into 64 times. So now I got 125 divided by 4, which gives me 31.25. Well, we can't take 0.25 of a drop. So what we got to do is we got to round to the nearest whole number if possible. So this 1 here is the whole number. And I'm going to look behind it, which is 0.2, right? That 2. And I'm going to ask myself, is this 2 equal to or greater than 5? And if my answer is yes, we're going to add 1 to the 1. If my answer is no, we're just going to drop off the decimal. In this case, 2 is less than 5. So my answer is going to be 31 drops per minute. Now, it said something went wrong. Somewhere's around the somewhere's around 4 hours later, something happened. Don't know yet. So it says after 4 hours. Well, how many hours are we infusing? It said we're infusing 8 hours. So I'm going to take this 8 hours minus that 4 hours. And it says we have a 4 hours remaining. So my answer is 4 hours remaining. Now we look at it and it says we have a volume of 700 milliliters. Well, we know there's a problem here, because if you were infusing 1,000 milliliters and the time is 8 hours to infuse for, and you've already taken up half the time, we should be down to half a bag. So there's something that happened, right? So we're going to have to do an adjustment here. And in this adjustment, I'm going to figure out what is my new flow rate and milliliters per hour. So I'm going to take that 700 milliliters remaining, and I'm going to divide that by the remaining time. And let's see what we get. We get 700 divided by 4. It says that we are to infuse 175 milliliters per hour. All right, let's go to the next part. The next part says, well, let's find the adjusted drops per minute. So I'm going to take that 175 milliliters over, and in the place of hour, I'm going to put the 60 minutes. And again, the drop factor doesn't change, so we're still working with that 15 drops per milliliter. And if you want to, you can reduce. I know the milliliters reduce. 15 goes in itself once, goes into 60 4 times. So we got 175 divided by 4, which gives me 43.75 drops per minute. Well, again, you can't take 0.75 of a drop. So what I'm going to do is I'm going to look at this whole number and go right behind it and say, okay, is this number greater than or equal to 5? And in this case, it is. So I'm going to add 1 to the 4. I mean, to the 3, making it a 4. So now I got 44 drops per minute. All right, we are almost done, guys. Now we got to determine if the adjusted is safe or not, if it's good or not. So I'm going to go back up here. And what was my original drops per minute? It's 31. And then we got our adjusted, which is 44. So the formula for this is my adjusted drops per minute. And I'm going to go ahead and write the number up here, 31, for my original right here. So I'm going to go over some stuff with you right quick. Minus my original, or you can call it your order. If you want to call it order, you can. Drops per minute. All divided by the original, or again, the order, drops per minute, all times 100%. I want to talk to you what happens to these units. And because when I rewrite this, I'm not going to put the units with it. So what if I had 2 drops per minute minus that drop per minute, all divided by drops per minute? What happens is 2 minus 1 leaves me with drops per minute, all divided by drops per minute. Well, whenever we divide fractions, we have this rule. It's called keep the first, change the operation, and flip the second. So when we do that, now I got drops per minute over, or minute, or drops over minute times minute over drops, which reduces down to 1. 1 times whatever number we got. So knowing all this, I'm going to erase this mess. Knowing all this, when I plug in my numbers here in this formula, my units reduce out. I'm not going to need to put them in there. All right, so let's write this. Let me clean this up. Hopefully y'all wrote it down. Let's just clean it up. Save some paper room right here. All right, so let's rewrite this formula. I have the adjusted drops per minute minus their original, all divided by the original, and then we're going to multiply it by 100%. So now we have 44 minus 31, which is 13, over 31 times 100%. 13 divided by 31 gives me this long decimal. I'm going to go ahead and write it out. Oops. And then we're going to multiply it by 100%. Sorry about my messy writing there. Now, when I multiply that by 100%, that changes everything a little bit. And it gives me 41.93548387%. Now, depending on the protocol, where you're working at or who you're working for, or if you're in a class and the instructor is teaching it on where you're going to round. In this class, I want to round to the nearest whole number. So since we're going to round to the nearest whole number, I notice that it's this number 1 here. So I'm going to look behind it, ask myself, is this equal to or greater than 5? In this case, yes, it is. So I'm going to add 1 to the 40, to that 1, making 41, 42%. Now, let's talk about this. Let's talk about that 42%. What do I know about variations? And what would be my action plan? All right. Most places has a protocol of 25%, a variation of 25%. So let's talk about what that actually means. That means we got from negative 25% to 0%, and 0% to a positive 25%. And in this window here, whoops, we're going to call it good. Now, let me explain something. If it's 0% variation, if this number would have came back to be 0%, we're going to say it's good. However, it is perfect, because then that means the adjusted is the same as the original flow rate, and there is no change. We're just starting back up. That is great. However, if it's not 0%, then we're going to be talking about an area on the outside. So from 0% to positive 25%, we're going to say it's within range. So if it goes from 0 to positive 25%, it's within range. However, it is the adjusted flow rate is a little slow in this case, but we're going to call it good. Okay. However, if it falls on the outside of 25%, like 27% and so on, we're going to have to say we need to increase the adjusted flow rate because the adjusted flow rate is too slow. Okay. Now, let's talk about what happens when it goes from 0 to negative 25%. Well, we're going to call that good. However, it's within range if it goes from 0 to negative 25%. But the adjusted flow rate is a little slow. I mean, excuse me, sorry, a little fast. But as long as it falls in this window here, we're going to say it's good. However, if it falls on the outside of this negative 25%, so like negative 27%, negative 30%, and so on, then we're going to say decrease. We're going to decrease the adjusted flow rate because the adjusted flow rate is too fast. So let's look at what we got here. We got a positive 42%. This tells me that the adjusted flow rate for this problem is too slow with a 42% variation. What are we going to do? The adjusted flow rate needs to increase. Which I'm not a nurse, so looking at how many drops per minute versus how many drops per hour, this is a red flag, right? So you'll have to do protocols. But this is math class, and I just wanted to kind of give you an idea of what to look for, and I hope this helps.